Hello there. So today I'm going to talk about projectile motion and do a problem related to projectile motion. So projectile motion is an example for two-dimensional motion. So projectile motion is an example for 2D motion, where what we do is that we apply kinematic equations in two dimensions. Okay, so what we usually have is an xy coordinate system. So the horizontal axis is the x-axis, then the vertical axis is our y-axis. So anything that moves in this coordinate system as a function of time can be described by two-dimensional motion. Now, the thing is that in this case, instead of studying two-dimensional motion, what we do is that we break up into two one-dimensional motions. Okay, so that's what we do, and this is relevant for projectile motion as well. Instead of studying the two-dimensional case, we basically break it down to two one-dimensional motion. So in this case, we have the x motion, or like motion along the x direction, and the motion along the y direction. So along the x direction, we apply kinematic equations. So we are going to apply kinematic equations along the x direction, and also we are going to apply kinematic equations along the y direction, and then combine those equations using time, because time t is an invariant. It does not depend on the specific dimension, the x direction or the y direction that you are applying the coordinate, you are applying the equations. Time is basically invariant. So we combine the x motion equations along with the y motion equations using time. Now, what are these kinematic equations? So just to recap, to give you an idea about kinematic equations, we mainly have three kinematic equations. The first one is velocity final equals velocity initial plus the acceleration multiplied by time. And then number two, the separation or the distance, I can call that x final minus x initial equals v initial multiplied by time plus 1/2 acceleration multiplied by time squared. And number three is final velocity squared equals initial velocity squared plus twice the acceleration multiplied by x final minus x initial. So these are the kinematic equations that we are going to use. So for example, if you are studying the x motion, then this would be x final and x initial, velocity in the x direction, acceleration in the x direction. But if it's you are studying y motion, then you will replace this by y final minus y initial, y velocity and acceleration in the y direction. So that's a basic recap of how to apply kinematic equations in projectile motion. Now let's try to apply this to a simple problem. Okay, so this is a problem where you have a football player kicks a ball during a game. Initially, now this t equals 0 represents initial conditions. Initially, the ball leaves the ground at a point O, so that is at this point, with an initial speed of 28 meters per second at an angle of 50 degrees above the horizontal. So this is the angle 50 degrees and the speed is 28 meters per second. So then the projectile, the ball will go like this in a parabolic trajectory, and it might hit the post. So let's see what's going to happen. So the first thing they're asking is calculate the time when the ball reaches its maximum height. So maximum height, so that means we are in part A, we are looking at the y motion. Okay, so we are looking at the y motion. So the first thing that we need to do in this case is decompose the velocity that makes an angle 50 degrees with the horizontal into its x and y components. So if we look at the initial y velocity, you can see that's going to be the starting velocity, which is 28 meters v naught sine theta. Okay, so v naught would be 28 sine 50 degrees. So that is going to give you the starting velocity for this particular problem. So that value is, so I'll write it as 28 sine 50 degrees. Okay, uh, and then we need to look at what is the acceleration in the y direction. The acceleration in the y direction is going to be minus g, or the gravitational acceleration. So numerically that would be minus 9.8 meters per second squared. Now why is there a minus sign? Because this is the reason. Acceleration velocities are vector quantities, so the direction matters. If we consider up as the positive direction, then gravitational acceleration is always pointing down in the downward direction. So the acceleration is in the negative direction compared if we consider this as our positive direction. So that's the reason for the acceleration we put a negative sign over here. That's the reason. Okay, so these are the starting velocity in the y direction and the acceleration in the y direction, which is going to be constant. It's the same value throughout all motion. It's a constant acceleration. So if I give you another important idea, these equations are all for constant acceleration valid. These equations, kinematic equations, are valid for constant acceleration motion. Motion with constant acceleration. That's where we can apply these equations. Just another important point for those things. And now let's try to find out the maximum height. At maximum height, an important thing that's going to happen is that at maximum height, the velocity in that direction is going to be zero. This is very important. Velocity is going to be zero. So what we do is that we apply one of those equations, kinematic equations, in the y direction. So for y direction, I'm going to apply one of those kinematic equations, namely this equation v final equals v initial plus acceleration multiplied by t. That's the equation I'm going to apply. V final in the y direction, since it reaches maximum height, that's going to be 0. V initial would be 28 sine 50 degrees, which is this one over here, plus the acceleration in the y direction, it's minus g, it's negative g, multiplied by the time it takes to reach the maximum height. So this is the value that we need to figure out. So from here you can see it's a simple algebraic equation. So when I solve this, you can see I'll get t equals 28 sine 50 degrees divided by 9.8, and this is going to give me a value of 2.2 seconds. So the time it takes for the football to reach its maximum height is 2.2 seconds. And what I did was that I simply used one of the kinematic equations to figure out this parameter time. Now so this is part A. So we did part A. Now let's go to part B. In part B, the football hits a wall 3.9 seconds after being kicked. Calculate the height of the ball when it hits the post. So it's referring to this particular diagram over here. So you can see this diagram here. That's the same diagram that they are using in part B. So what happens is that there's this horizontal surface. The ball starts at point O and it goes in a parabolic trajectory like this. And after t equals 3.9 seconds, the football is going to hit a post. Okay, and let's say that that point is A, and we are trying to find this particular height, what we call h. Okay, so that's what we are trying to find out. This angle, the starting angle is 50 degrees, and the starting speed is 28 meters per second. All those informations were given in this at the beginning of the problem. So how are we going to solve this? Again, they are looking for a height, calculate the height. So that's a y displacement. So I'm looking again at the y motion of this projectile motion, and I'm going to consider uh, the height in this case, how the height changes. So I'll have this equation y final minus y initial equals v initial in the y direction multiplied by time plus 1/2 the acceleration in the y direction multiplied by t squared. So this is the equation that I'm going to use. You can see initial y position, that means over here, this point, that's like, t equals 0. So initially the y position is 0. So I have to put 0 over there. And then y final is this position. When the ball after 2.9 seconds, when it hits point A, that's my y final position, and that's what I called this h. Okay, so this is going to be my h. Okay, and then I can simplify my left hand side of this equation simply as h equals v initial in the y direction. We know that that is 28 sine 50 degrees. Okay, and then the time is this value, which is 3.9 seconds. So I have 3.9 seconds plus 1/2. Ay is the acceleration due to gravity, and in the y direction it will have a numerical value of minus 9.8 times 3.9 squared. So simply I need to solve this expression to obtain the height above the horizontal when the ball hits the post. So that value I'm going to get up to two significant figures if I solve this expression, 9.1 meters. So that is my final answer for part B. H is 9.8 meters. Part C, the final part, calculate the magnitude of the ball's velocity as well as its direction expressed as an angle from the horizontal when the ball hits the post. So we know, again, I'm going to sketch that previous situation. At O, the ball leaves at an angle and then it goes like this, and then it's going to hit this post at a certain height, at a height h. So this height, as we calculated in part B, is h equals 9.1 meters, and the time it takes is 3.9 seconds. So at this point, the velocity vector is pointing in this direction. So what we can do is that we can divide the velocity in an x direction and a y direction. Okay, and then so let's call this like v final in the x direction and v final in the y direction, and then also we can find an angle, let's call that angle alpha. So what we are trying to do is that we are trying to find v final in the x direction, then v final in the y direction, and also this angle alpha that makes with the horizontal direction. Okay, so since this is a depression, an angle below the horizontal, I will expect a negative value for the angle alpha. So let's try to do this. So I'm going to first consider the x motion. In the x direction, if I consider x motion, the starting velocity would be in the x direction, that is v naught cosine. It's going to be cosine instead of sine, because we are looking at the horizontal component. I have cosine 50 degrees, or in other words 28 cosine 50 degrees. Now if I look at the x motion, I can again apply the final velocity in the x direction equals the initial velocity in the x direction plus the acceleration in the x direction multiplied by time. But as you know, in projectile motion, the acceleration in the horizontal direction is zero. There's no acceleration in the horizontal direction. So as a result, the final velocity in the x direction is equal to the initial velocity in the x direction, which is 28 cosine 50 degrees. Okay, now so that's the so this is, so we figured out this part, that is the final velocity component in the x direction. Now for the vertical component in the y direction, for y motion, I can find out that component again using the same equation. V final in the y direction equals v initial in the y direction plus the acceleration in the y direction multiplied by t, and then v final in the y direction is equal to v initial in the y direction, which is 28 sine 50 degrees plus minus 9.8 multiplied by 3.9, because 3.9 is the time it takes for the ball to start from point O and hit the post at, I believe, position A. So then when you solve this expression, you are going to get a value of minus 16, numerical value of minus 16.8 meters per second. This value over here, that's basically 18 meters per second. So you have the x component as 18 meters per second, and also we calculated the y component, that is minus 16.8 meters per second. The minus sign tells you that the velocity is now pointing in the downward direction as shown here, which makes sense because the projectile, when it impacts the wall, it's in a downward depression angle, a downward angle. Okay, so now how do we find the magnitude of the ball's velocity? How do we get the magnitude? We use the vector addition of these two vectors, v final x and v final y. So the magnitude of the velocity is given as the square root of v final x squared plus v final y squared. Okay, and then you substitute the values. You get 18 squared plus minus 16.8 squared, and the answer would be 24 meters per second. So that is the magnitude of the velocity when when the football hits the post. Okay. Now the angle alpha, you can simply use the inverse tangent of the velocity, the final velocity in the y direction divided by the final velocity in the x direction, and this would give you inverse tangent uh, minus 16.8 divided by 18, and you'll get a negative value for the angle minus 43 degrees. Okay, so that means the angle is below the horizontal. So if this is the horizontal, the angle is below the horizontal, making an angle like 43 degrees below the horizontal. So this is how we figure out the magnitude of the ball's velocity, and this is how we figure out the direction of the ball's velocity as an angle from the horizontal. So I hope this this explain how to apply kinematic equations for a projectile motion problem. If you have questions, please comment. If you like this clip, please like and subscribe to my channel. I'll be posting similar problems and solving them on my channel so that you can understand how to apply these equations in physics problem solving. I hope you have a wonderful day. I'll catch you soon. Bye bye. Thank you.